All right, so Chapter 11, Lesson 3 is measures of variation. Okay? So, the first thing we wanted to do is, for the warm-up, is we wanted to define all of these vocabulary. So for quartiles, who has quartiles? So, let me just read them. The quartiles, we have the values. The quartiles are the values that divide the data set into 4 equal parts. The first and third quartiles are the medians of the data less than the median, and the data values greater than the median, respectively. So in other words, for the first and third quartiles, it's the median of the lower half and the median of the upper half of the data. The interquartile range is the distance between the first and third quartiles. And to find that distance, we will subtract the 2 values. The range is the difference between the greatest and the least values. And how do I find the difference? Subtract. Very good. All right, measures of variation of a data set are shown below. So here we have a data set that's already in order from least to greatest. The median, of course, is in the middle. Okay, this, since we have an even number of data items, we had to add the 2 numbers and divide by 2, right? So, if I added 3 plus 4, divide by 2, will I get 3? No. Will I get 4? No. The average of those 2 is something in between, right? So that means the median is not 3, not 4, it's right in between those 2 numbers. Is everybody clear? So the quartiles, here, this is the first quartile, and the first quartile is, look at that, it's right in the middle, right? It's right in the middle. So it's the median of the lower half. You see that? Yeah. And then over here, the third quartile, right in the middle, right in there, it's the median of the upper half. Okay? That's what the first quartile and third quartile are. Okay? So, let's take a look at how we get those. The example 1 says find the measures of variation for the data. Now when we talk about measures of variation, when we're talking about the measures of variation, we're talking about the range, the quartiles, first and third, and the interquartile range. Okay? We also need to find the median. Okay? So when I say the quartiles, first, third, and the median. Okay? Okay, so to find the range, well, for this, the first thing we need to do is put the data in order from least to greatest, okay? Well, we can just look at this and see which one is the greatest and which one is the least, right? So the greatest is 70, and the least is 1. So to find the range for the speed of these animals, it's going to be 70 minus 1, which is 69 miles per hour. To find the quartiles, you have to put the data in order from least to greatest. Okay? So here are the numbers in order from least to greatest. They already did that for us. And to find the median, because we have 6 numbers, right, we're going to add the 2 middle numbers and divide by 2, so the median is 27.5. Everybody see that? Then we want to find, see, the median then would be right here, somewhere in the middle. Now to find the quartiles, quartile 1, the first quartile, is the median of the lower half. So here is the lower half. When I say lower half, I mean the lower numbers. Is everybody clear with that? Bless you. So here, the middle number of these 3 is 8. So the first quartile is 8. For the third quartile, the median of the upper half, and again, that means the median of the higher half of the numbers. So here, the third quartile, the third quartile will be 50. Is everybody with me? Now, to find the interquartile range, we're going to take the third quartile minus the first quartile. So that's going to be 50 minus 8, which is 42. So the range is 69, the median is 27.5, the first quartile is 8, the third quartile is 50, and the interquartile range, IQR, is 42. Okay, so here we have example A. It says determine the measures of variation for the data. So the first thing we need to do here is put the data in order from least to greatest so we can get our medians, right? So let's do that. So here we have our unorganized stem and leaf plot, and now we need to organize it. So now you guys, I'm just going to move them around. You can make your second stem and leaf plot and organize them. All right, so here we have our data in order from least to greatest, and now we can find our median, our first quartile, our third quartile, and our range. Okay, so to find the median, we want to get to the middle. So how many numbers do we have altogether? 10. Oh. So that means we're going to we have two numbers, two middle numbers, right? So 10 divided by 2 is 5. So 1, 2, 3, 4, 5, 60. And then 1, 2, 3, 4, 5, 61. Those are our two middle numbers. Okay. So we add the two middle numbers, divide by 2. We get 121 divided by 2. So the median is 60.5, right? So now we want to find the first quartile. Now that 60.5 is in between these two numbers, right? So that means that we want to find the median of the lower half. That's quartile 1. See what I underlined in red? We want to find the median of that lower half. So there are 5 numbers in there. So how many middle numbers are going to be there? 1 middle number, because there's 5, right? So, and then it's going to be the third number. So 1, 2, 3. There is the the first quartile. So the first quartile is, what's the number? 58. Very good. Not just 8, 58. So now we're going to find the median of the upper half, which is going to be for quartile 3, right? So that's going to be 1, 2, and it's the third number. So what's that, the quartile 3? 64. Very good. 64. And then the range is the difference between the highest number and the lowest number. So what's the highest number? 71. And what's the lowest number? 56. So the range, 56. So we have 71 minus 56. So 71 minus 56 is equal to? Got it? All right, and then for the last thing that we want to do is we want to find the interquartile range, which is we're abbreviating IQR. Okay, so how do I find the interquartile range again? Very good. So here we're going to have 64 minus 58, which is what? So the interquartile range is 6. Is everybody clear? Now, I want to let you know that if your interquartile range is a low number, okay, if it's a low number, that means that that your data for that middle half are very close together. Okay? So if your range is low, right? If your range is low, then it's the numbers are very close together. Okay?
Is there an outlier?
So now we're going to find outliers and analyze the data. Now, you need to know what an outlier is. So please make sure you write down this definition. Please make sure you write down this definition, the outlier. The outlier is a data value that is either much greater or much less than the other values in a data set. An outlier is more than 1.5 times the value of the interquartile range. Okay? See this right here? That's an inequality. That sentence tells me an inequality. So we need to go ahead and translate this English to math. So now we're going to translate. So if I have, it says an outlier is more than that. If this is more than that, what kind of inequality is more than going to be? Is that going to be greater than or less than? That's going to be greater than. Very good. So the outlier, I'll just call it X, has to be greater than, what word here tells me an operation? Times. That tells me what? Multiply. Okay, so we're going to multiply 1.5 times the value of the interquartile range. So it's going to be 1.5 times the IQR. That is going to give us the outlier. Okay, so the outlier, if a data value is an outlier, it has to be greater than 1.5 times the interquartile range. So this is the formula that you're going to use. You must know that formula. Okay? So here, you don't have to write this part down. I'm just going to talk about it. If you want to write this down, you can. The ages of candidates in an election are 23, 48, 49, and so forth. We want to name any outliers in the data. So in order for us to find the outliers, these are the steps we need to take. Okay, so the first thing we want to do is we want to find the interquartile range. The good thing is that this data is already in order from least to greatest for us. Okay, so to find the interquartile range, we need to find the median of the lower half and the median of the upper half, which means we need to find the median first, right? So the median of this data, let's see, 1, 2, 3, 4, 5, 6, 7. So 7 divided by 2 is 3. 1, 2, 3. But that's not the middle one, right? We got to count one more. So 55 is my median. So to find the quartile 1 and quartile 2, we look to see the lower half and the upper half. So 48 is my quartile 1. Does everybody see how that works out? In the upper half, the median of the upper half is quartile 2. Quartile 3. So there is your third quartile. Let's see. So now to find the interquartile range, we're going to subtract quartile 3 minus quartile 1, which is 63 minus 48, which gives us 15. That is my IQR. Right? So now we want to multiply the interquartile range times 1.5, which is what the formula was that we came up with up here, right? So 15 times 1.5 is 22.5. Now, if I have any data that is, well, no, 22.5 is my, the next step. So letter C, the third step, letter C here, is to find the limits for the outliers. So the first thing I need to do here is find the lower limit. The lower limit is the first quartile minus what I got for B, which was 22.5. Is everybody with me? So 48 minus 22.5 is 25.5. Then I want to find the upper limit. To find the upper limit, we're going to add to the third quartile. So we have 63 plus the 22.5 gives me 85.5. That is my upper limit. So that means that if I have any data that is below 25.5 or above 85.5, then those are outliers. Do I have any data that goes beyond those two numbers? 23 is lower than 25.5, right? And I think that's it, right? So 23 is the outlier. So here, for the got it, we have the lengths in feet of various bridges. And we want to name the outliers in the data set. Okay? So the first thing we want to do is we want to find the interquartile range. To find the interquartile range, we need to subtract Q3 minus Q1, right? And in order for us to find those, first we need to find the median, right? So the median is the middle number here. So 1, 2, 3, 4, 5. We have 5 numbers. How many middle numbers are we going to have? Just 1, right? 5 divided by 2 is 2. So the third number is the middle number, right? So the third number, 1, 2, 3. There is my median. So now we're not going to use this anymore. So now I want to find the quartile 3. Now in order for us to find quartile 3, quartile 1, now there's only 2 numbers in the lower half, right? So what do I have to do with those to get the quartile 1? Add them and divide by 2. That's how we find a median of 2 middle numbers, right? So the quartile, this is going to be quartile 1, and I'll write the number above. So quartile 1 is 169.5. So we added these 2 numbers together and divided by 2. That gave us 169.5. So now to find quartile 2, we need to add the 2 upper half, the 2 data values in the upper half, and divide by 2. So we ended up, after we added the top 2 numbers there, we divided by 2, we got 737.5. So in order for us to find our interquartile range, we're going to subtract 737.5 minus 169.5. All right, so that gives us 568. Okay, so now in order for us to get closer to what our limits are, we want to multiply the interquartile range, which is this number up here. We're going to multiply 568 times 1.5. All right, so 568 times 1.5 gives us 852. Yes. All right, so we get 852. Now that is a number that's going to help us find our limits. Okay, so to find the lower limit, we're going to take quartile 1 minus 852. All right, so to find our lower limit, we took quartile 1, which is 169.5, and we subtracted B, which was 852. And that gives us our lower limit. To find the upper limit, we're going to take quartile 3, which is 737.5, and then we're going to add 852. Is everybody clear? So when we do that, so this is our upper limit, okay? So, do I have any numbers that are lower than this negative 682.5? No. Do I have any numbers that are higher than 1,589.5? No. So, do I have any outliers in this data? No outliers in this data. So, example B, we have the lengths in feet of various bridges are these. We want to name any outliers in the set, okay? So, the first thing we want to do is we want to find our quartiles, okay? So, the median is the first quartile, or the second quartile. So, we have 1, 2, 3, 4, 5 numbers. So, that means we only have one middle number. So there's the median. So 275 is our median. And again, once you get that median, you're not going to use it again. Is everybody clear? All right, so that's the median. So now we want to get the quartile, first quartile, and the third quartile. So when we do this, we are going to well, we only have two numbers, right, in the lower half. So to get to the median there, we have to add those two numbers and divide by 2. And you will show your work, okay? Or you can use your calculators for that. But you'll write down what they are. So you're going to add 88 plus 251, and you're going to divide by 2, and then you're going to end up with 169.5. Got it? Then, for the third quartile, we're going to find the median of the upper half. And again, there's only two numbers there. So to get to the median, we're going to add them together and divide by 2. So when we add 354 plus 1,121, we end up with 731.5. So now we want to find the interquartile range. To find the interquartile range, we're going to subtract quartile 3 minus quartile 1. So we have 373.5 minus 169.5, which gives us 568. That number gets multiplied in step B times 1.5. Okay, so now we're going to multiply that 568 times 1.5. That gives me 852. That is my B. Is everybody with me? All right. So now we find our limits. The lower limit we find by subtracting quartile 1 minus B, which was the 568. So, I'm sorry, the 852. If we subtract 169.5 minus 152, that gives me a negative 682.5. Now to find the upper limit, we're going to take the third quartile and add B, the 852. When we do that, we get 1,589.5, right? So now those are my gates, right? Do we have, let me put the numbers back up there. Do we have any numbers that are beyond those gates?
Yes.
We do?
No.
Look at those numbers again.
Yeah, 88.
88?
No, that's the...
Remember, that first lower limit is a negative.
Oh.
You see that?
Yeah.
So, once again, do I have any numbers that are beyond those gates? No, we do not. So, in this problem, we don't have any outliers.